Precalculus 7.3 hyperbolas. So we have a lovely textbook definition of a hyperbola here. We're not going to worry a lot about that. We just really want to dig into what these equations look like. So the thing that you might notice right away is that we still have an x squared over a number, we still have a y squared over a number, but there is a minus sign in between them now. So that is how you can tell the difference from a hyperbola to an ellipse and a circle. So circles and ellipses have plus, hyperbolas have minus. So when we start with x, when it's this x part is first, it means that it opens in the y, or in the x direction, opens in x direction, which I really mean horizontal. My x-axis is horizontal. And when our y is first, it's going to open in the y direction, which is vertically. So that's the first really important thing. This means that when we're looking at a hyperbola, our order matters. So when we worked with ellipses, a was always the bigger one. When we're looking at hyperbolas, a squared is always our first one. So the order matters instead of the size. So a squared is first. Our equation for our foci is really similar to what we did before. It's c squared equals a squared plus b squared. So if we think about how there's a minus sign in our equation for our hyperbola and a plus in our equation for a foci, it's really backwards from what we did for ellipses. And we've got some graphing steps here. We'll look at more vocab on the next page too. That's kind of more mixed in when it's important. So first we're going to graph our center, which is HK. Then we're going to use A and B to draw, instead of an ellipse, we're going to draw a box. Our third step is we're going to draw asymptotes. And those connect the corners of the box. And last is we're going to actually graph the hyperbola. So we're going to go ahead and look at a graphing problem now. So first I'm going to graph a hyperbola. I need to pay attention to my center, and it's a little bit tricky because my center, remember, is HK, so an XY coordinate, and because Y is first, I don't want to mix it up and say -4, +2. It's really 2, -4. So my X is going to be 2, my Y is -4. Those are always opposite in sign. So 2, -4 would be a point right here. That's my center. And then next I want to draw a box. So because y is over 4 and 4 is 2 squared, that means I'm going to go 2 units up and down for my box. So it's really like an ellipse. X is over 9, which is 3 squared, so I'm going to go 3 units right and left. So this is like what we did before. So 2 up and down, 3 right and left. But then instead of connecting those and trying to make a curve and doing an ellipse, we are just making a box. So now I'm going to go ahead and connect for my asymptotes now. Asymptotes. So remember on the other page we wrote that they connect the corners of the box. So I am drawing from one corner to the other and trying to make them all line up. All right, so then we're going to draw our graph. So because my y is first, it's going to open up and down. And so I'm going to have a vertice right here on the box and right here on the box. And then when I draw my graph, I'm going to go through my vertice and get closer and closer to my asymptotes. Same thing on the other side, through the vertice, closer and closer to the asymptotes. So other information that we want to add in and I'm going to grab a different color for this, is that my axis, that if I was going to draw that through the box, the axis that the vertices are on is my important axis. That's my transverse axis. So before it was major axis, but that doesn't really make sense here because it's not necessarily bigger. So it's my transverse axis and it connects the vertices. And because it is A units on each side from the center, the length is 2A. And then the other vocab thing that I want to add in is that connecting what would be my covertices, except I don't have them because there's no graph over there. There's no covertices. So covertices belong to ellipses, but not hyperbolas. This other axis is called the conjugate axis. So you can still think about like conjugate and covertices like not as important. And this one is B units on both sides, so it's going to be 2B. It's the one that the axes are not on. It makes a right angle with the other one. So that's my conjugate axis. So that's just like some extra vocab. And then we want to go back and find characteristics. So I'm going to go here to, oh, look, I did some stuff before. I guess I need to erase that from before when I was working on this. So my parts of my graph that I need to identify are first, of course, my center. I already have my center from up above, center. So I already have that characteristic. The other characteristics I need are foci and asymptotes. So let's do foci next. And so my foci, I know that I have the equation c squared equals a squared plus b squared. It's great because I'm adding a squared and b squared. I can't really screw it up. So that's going to be 4 plus 9. So 13. So I'm going to have plus or minus the square root of 13. So what that means, if I start at my center and I have my parabola up, my parabola down, here are my vertices, my foci are going to be square root of 13 units up from the center and square root of 13 units down from the center. If it was right and left, it would be to the right and left. Okay, so it's still like that hyperbola is going towards where one of the foci are. So kind of like the parabola goes towards the focus. So let's see. That means my center, what was my center at? My center was at 2, -4. So I'm keeping the 2, that's my x value. It's the y value that's going up and down. So my foci is going to be 2, comma, -4. And then I'm going to move up and down 13, square root of 13 units. So plus or minus square root of 13. So that's going to be my foci. And that is a 13 right there. All right, so I got that. And last, I want the equation for the asymptotes. So if I look inside that box, which is really heavily drawn on now, so I'm going to just maybe redraw it down here. I think about where that center was. I got the box by going up 2 units and down 2 units and right 3 units and left 3 units. So if I'm thinking about a line that goes through that, I really need a slope and a y-intercept. So I know that my slope was up 2 and over 3. I know that my other slope was down 2 over 3. So it's plus or minus 2/3, and I'm getting that from the box. So the top number is that change in y, the bottom number is my change in x, so plus or minus square roots of 3. The other thing that I need to be able to write the equation for an asymptote is I need a point. Well, I could write two different equations, but they both go through that center. So if I use the center, if I use that 2, -4 as my x1, y1 in point slope form, then in just one step, I can do an equation for both. So I'm going to use point slope form. I'll write that out for you really fast to jog your memory. So let's see, this is going to be a y minus a -4, so y plus 4 equals, my slope is plus or minus 2/3, and then I have x minus 2. So that's going to be my equation that I could use. So we don't want to change that to y equals mx plus b unless we have to. So the next couple, we're going to just practice writing equations again. So first, we're always going to graph our info and then see where we go from there. So I'm given foci. So 1, -5, and 1, 1. So those are my foci. So right away I could get the center. I know I haven't even read the second part of it yet, but my center then is going to be right in the middle of those two, which is 1, -2. And I could even figure out from my center to F, to one of my foci, that's that little C. So maybe I want to just put a little C right here. C equals 3. So that's that foci equation, C squared equals A squared plus B squared. And then because my foci are located vertically, I know that this is going to open vertically. So I know it's going to open vertically, which means my y is first. So I'll have y minus something squared minus x squared over something equals 1. My transverse axis is my important axis. And remember on the last page, we wrote down that the transverse axis was 2a, because from my center, it's up a and down a in this case. So 2a equals 4. So a equals 2. So I know that, but I still need to have b. I need a and b to write this equation. So c squared equals a squared plus b squared. C is 3 and a is 2. So we're solving for b squared. So 5 is equal to b squared. And then we want to put this all together. So I am going to have y first. So I need to have y plus or minus something. My center is 1, -2, so y plus 2, quantity squared. And the y is on my transverse axis. That's my a, because it's opening in the y direction, not because a is bigger, but because it's opening in that direction. If a is 2, 2 squared is 4, minus. And now I've got a quantity with x. I'm going to have x minus 1 squared over. And then in my x direction, I have b, which b squared is 5. And then that's going to equal 1. So that is writing an equation. And we're going to do this again just because I think these are the ones that are tricky for us. The graphing is usually pretty straightforward. It's these where we have to think. So we're going to go ahead and graph -3, 3, 6, 9, 10, -3, -2. These are my vertices. And so my center is going to be between them again. So let's see, my center would be -3, 4. All right. From my center to one of my vertices is A. So I can get that right away. 1, 2, 3, 4, 5, 6, which makes sense. If I look from the 4 to the 10, I'm 6 units away. From the 4 to the -2, I'm 6 units away. So I have A. My conjugate axis, conjugate, is my less important axis. So that gives me 2B, because it's B units on both sides of the center. So B equals 3. And I think we're ready to go ahead and write an equation again. Because these are located vertically, it's going to open vertically. So y is first, because I can draw a vertical line through my vertices. If they were on a horizontal line, I would have x first. So I'm going to have y minus, my y value at my center is 4, so y minus 4 squared. Up and down in the y direction was 6 units, so 6 squared is 36, minus x minus, my x value here is a -3, so plus 3 squared, over. In my x direction, that's going to be b. That's my less important direction because it's not opening in the x direction. So 3 squared is 9, and then I have equals 1. So looking at eccentricity. Eccentricity of a hyperbola is found the same way, the same formula, which is E equals C over A. For an ellipse, it's between 0 and 1. Remember, circle is when it equals 0. An ellipse is between the 0 and 1. And then if I have something greater than 1, it's like the hyperbola or the ellipse almost like collapses on itself or breaks apart. Broken ellipse kind of is what we could look at. And so we have a hyperbola. And so I just have like a couple pages here where it's just kind of interesting to look at how that works. So you can see the circle, and then from 0 to 1, and then the 1 for a parabola. E equals 1 is a parabola. It's like the ellipse just broke apart, and then you can see what happens as we have those different kinds of values. It's just kind of a neat graph. And then here's some more showing you different eccentricities and how that affects our hyperbola. So here we're going to go ahead and just practice doing it really quick. So remember, we have E equals C over A. So A is going to be the first one, right? So A is going to equal the square root of 32, but I still need to find C. So order matters, A is first. So C squared equals A squared plus B squared. So C squared equals 32 plus 25. So C squared equals 57. So when I go ahead and do E in this formula, I'm going to have the square root of 57 over the square root of 32, which we could go through and simplify, but they're going to want us, at least in the book, to have a decimal. I think it's easier in my calculator to do the square root of 57 divided by 32. So like I would do a square root and then parentheses and then divide that. And I just find it works out better for me. And we kind of know, because it's an ellipse, that we shouldn't have something that's like 0.2, right? It needs to be greater than 1. And we get 1.33 when we divide that out. So I would try that with the calculator, make sure you get the right answer. So last, we're looking at just classifying. So, and the reason that we have to classify, well, we always like to classify conics, right? We like to look at something and figure out, like, what the heck am I graphing? What kind of shape is this? And so by classifying conics, when we say conics, we mean a parabola or a circle, an ellipse, or a hyperbola. So we're looking at all those different shapes, but the difference is that we can't, before now we've been able to just look at them and kind of tell, but we have this weird XY term, and that's because we have tilted conics. So that means instead of having an ellipse that's like this, I could have an ellipse that's like this, where it's just kind of tilted. And that involves trig if we do graphing, and so we're not really graphing or messing around with them a whole bunch, but we can still go through and we can do this classifying step. So we do what's called a discriminant, and discriminant is still, it looks like part of the quadratic formula. It's b squared minus 4ac, but we write them capital here because I don't have what looks like a normal quadratic. I have a second degree equation, but it doesn't look like a quadratic, right? I have my ax squared, my b is multiplied by my xy, and my c is multiplied by my y squared. So I don't care about the d, the e, or the f. We do not use them. So you do need to memorize this. So if it's less than 0, it could be either a circle or an ellipse. And so then we just use kind of our common sense to figure out which it is. Parabola if the discriminant equals 0, hyperbola if it's greater than 0. So you will have to memorize that. So we're going to practice it really quick. If I can find my right page. All right, so here's 5. So we are going to practice. Remember, A is for our x squared, B is our xy term, and C is our y squared term. So we don't care about the other ones. We're doing b squared minus 4ac. So b squared is going to be 5 squared minus 4 times 2 times 1. So that's going to be 25 minus 8. So I get 17. And because it is greater than 0, I'm going to say hyperbola. All right, on the next one. My a is my x squared, my b is my xy, and I don't have any xy terms, so I'm going to write down that b equals 0. C is y squared. Same formula, b squared minus 4ac. So 0 squared minus 4 times 4 times 4. So 0 minus 64, negative 64. So because it is less than 0, I have either a circle or an ellipse. So I'm going to use common sense to figure out which one. And because I don't have an xy term, that means it's not tilted. So let's just look at it. I have the same number in front of x and y. So that means if I was graphing this, I would be stretching it the same amount in the x and the y direction. And so it must be a circle. So circles can't be tilted either. That's another thing to think about, right? If I have a circle and I tilt it, it still just looks exactly the same. So because it is not tilted, because there's b is 0, and these are the same number, it tells me it must be a circle. All right, on the last one, A is 2, B is my xy. I almost screwed that up. C is with my y squared. So b squared, 4 squared minus 4 times 2 times 2. So 16 minus 16 is 0, so I must have a parabola. Which is kind of wild, right? Because we're not used to having a parabola with this x squared and y squared. But again, these are tilted. It's not going to be a parabola that's like this or a parabola that's like this. It could be a parabola that's like, it's even hard to draw tilted. So because they're tilted, they're just really weird equations and we can't look at them. So we need to have other methods to figure this out. So please do your homework. Please ask for help in class. And this is our 7-3 note.